This video has information about compareTo method, which is kind of related to sorting, what we've been doing in chapter 14. And so compareTo is also a lot like the equals method, the dot equals method. We're going to understand how it works and how it relates to sorting. That's our first goal. And then we're going to, like when you make your own object, like student, like we talked about how you can write if they're equal, like if student 1 is equal to student 2. We're going to talk about how you can tell if like one student is greater than or less than the other student. That's what kind of the idea of the compareTo method is. Okay, so I have up here in Eclipse, we have just a basic example here of if you have ints, right? We can certainly do an if that like if Max's IQ is less than Gunner IQ, right? Then we could do something like make fun of Max. Since I'm not very comedic, I don't really have a joke about Max here at all, but we could say then if that's not the case, so then Gunner must be greater than or equal to, then we could make fun, no wait, then Max, if Max is not less than Gunner, then he must be greater than or equal to, so here we could make fun of Gunner. All right, so that's how it works with ints. All right, but it becomes trickier where like what if I had strings, right? So like how do you order strings? So we have like, let's say string 1 is say like bumpkin, right? Or string 2 equals marmalade, marmalade. I don't know how you spell it, but whatever. Spelling's not my forte. But anyways, then like how would you tell which one is greater, right? We can do it for certainly for ints, but like what is true in strings? And so you can't do this. You can't just say if string 1 is greater than string 2. Pretty sure that doesn't work, right? Because that's how you do like an ints or doubles or something, and it's not going to work with strings, right? So if you want to do this with strings, you use what's called a compareTo method, much like if you want to say string 1 is equal to string 2, that's how you do it, right? You can check if they're equal, but you can also check if they're greater. And so how it works for greater is you just do the name of one of the strings, and then you do this compareTo method, and you pass in the other string, okay? And so when you do compareTo, there's one of three things can happen, and this is actually defined in the Java API a little bit. Like compareTo is a specific method, much like equals is kind of a very, very specific method. So it returns either a negative number, 0, or positive. And so it returns negative if the one here is less than the second one, then it returns negative. If they're equal, it returns 0. And then if this one is greater than the other one, it returns a positive number. All right, and so for strings, the way compareTo is defined is just alphabetically, right? So we could do if string 1 compared to string 2 is less than something like 0, right? Which I think is what would happen here because bumpkin comes before marmalade in the alphabet. If you put them alphabetically, so it would return a negative number, right? So basically you could check if it's less, you can system out, print, whatever, right? And then the other two things that could happen is it could be greater. So I could do it a second time and say, okay, if it's greater than 0, then it must come prior in the alphabet. So maybe I'm actually, let's do less like this. That's less. This should be greater than. And then if neither one of those is true, then they're going to be equal. Okay, so here I'm just going to system out print equal. Okay, so if we run this right now, it'll make fun of one of those two. It'll make fun of Gunner probably by the look of it. Make fun of Gunner, and then it'll say less here. So on this part, bumpkin is less than marmalade because it comes earlier in the alphabet, right? And if we did something that came farther down the alphabet, like Zachary.Farwell, something like that, then it should be greater because that comes farther down in the alphabet. So now it says greater than. All right, so now I'm going to have some test questions for you. And again, what compareTo does is if the first one on the left is less, it returns negative. If they're equal, it returns 0. And if this one on the left is bigger, then it returns a positive number. So I have two strings. I'm just going to do max compared to max. What do you think is going to be printed out in this test case? Pause the video, take a guess, and then unpause. Okay, hopefully you got a chance to look at it here. 3, 2, 1, bam. We get 0 because they are equal. So it returned an int of 0 because max is the same string equal to max. All right, next test case for you. We are now comparing pars to Zeeman. And again, what int? Well, actually, the int is, you're not going to know the exact number, but just is it positive, negative, or 0? All right, so here you go. Bam. All right, and so it's negative 10 because pars comes before Zeeman in the alphabet, so it's less. Okay, and the distance actually does matter. I don't think it really matters that you know that it's negative 10 versus a different number. As long as you know it's negative, that's all that matters. But if we tried something like Aaron here, I think it's going to be even farther from Zeeman, so I think it's even a stronger negative number. It might actually be how many letters away it is, A to Z. I'm not really sure, but the point is, all you really have to know is that it's negative. Next up, we're going to do, I mean, I know it's a pretty ridiculous comparison, but we're going to compare Westphal to Mitchell, see what happens in this case. So pause it, take your best guess. All right, hopefully you got that. It should be positive because Westphal is certainly greater than Mitchell. Only really alphabetically. In all other ways, Mitchell is better, but alphabetically speaking, no, actually it would be, this should be negative because Westphal comes, no, it should be positive because Westphal comes after Mitchell. So it will be a positive number because it's further down in the alphabet. All right, last test case here for you, just to show you what it looked more like in code, is we've got two strings defined in more the traditional way, and then you'd use their name dot. So I know I was doing it a lot different up here, but here I'm just defining them in the traditional way and doing string one dot compared to the other string. All right, and I didn't do the equals case here. I'm just doing is Billy less or more, right? And so again, you don't have to know exactly what negative number or positive numbers return, just is it negative or positive. So take a look at this one and see which print statement do you think is going to run. Hopefully you got a chance to look at it. And so Billy comes before Bumpkin, so it's going to be a negative number, going to be less. And so I think it should do the Billy is less, if I got this right. Okay, hopefully that gives you the idea of what compareTo does. And for strings, it's defined alphabetically. Okay, so next up is if we've made our own strings, not our own strings, our own object type, our own class type, you can define how the compareTo works. All right, much like you can define how equals works. So in this example, we have a student class, and it's got just two variables, the name of the student, and the GPA. Right, we've got a default constructor, and then one that passes in the name and the GPA. Right, so back when we did equals, we did it like this, where you can define, like if I have student1 dot equal student2, you can define when that returns true and when it returns false. And so for this particular example, I just made it so if their GPAs matched, then they were considered equal, right? You could also say if their names match, then they're considered equal. Oftentimes in practice, it would be based on their like student ID. That's how you tell if two students are equal. But really, you can define the equals however you want, right? In a very, very similar way, you can define compareTo however you want, all right? And so in this particular example, I'm going to make it based on their GPA. All right, so when you do your compareTo method, it's like equals that has to have this sort of exact heading, except it returns an int and takes an object. And then much like equals, you have to cast it into the object that we want from a generic object into the specific object of student. So it starts the exact same way, right? And then as far as the code does, you just have to sort of do these three cases. right? So we can do basically like if this object, so this dot get GPA, so the object that I'm inside of here, that is less than the other student dot get GPA, right? So if I am less or lower GPA, then we want to return -1, okay? And then we're going to do an else if, okay? And I would kind of pause this and see if you can even guess at what would go here. Okay, so hopefully you figure out that there's actually 3 different cases. So we could do sort of the reverse. So if this dot get GPA is greater than other student dot get GPA, then you want to return 1. It's greater. And then if it's not less, it's not greater, then they must be equal. So in case we would return 0. So I put a little comment here. GPAs must be. All right, and so that would define a compare-to method for students. All right, and so why this matters, all right, is, or how this relates to sorting, I guess, is we can imagine a scenario, right? We were just doing merge sort where I've got, say, like a bunch of strings here and I want to merge them, all right? And so it's going to use the compare-to method when it merges them, right? And similarly, I'm going to do an example of if we have a bunch of students and we want to merge them, we can use that compare-to. All right, so this will be a good review of kind of both how merge works and then how the compare-to method works. All right, so see if you can take a second and think, what would these look like if after they merge together? Okay, and hopefully what you figured out is that it's going to compare. So we're going to have an IDX, and it's just going to compare wherever that IDX is at. So right now we're comparing apricot to bumpkin. And apricot, because of the way compare-to is written for strings, it's going to do alphabetically and say this one is the lesser one, so it goes first, moves over this IDX. Now we're comparing Billy and bumpkin. So Billy is less, so Billy would slide there. We slide this over. Now it's going to compare tuna to bumpkin. Bumpkin is less. Take bumpkin, slide over this. We're just merging them together. Now we have munchkin compared to tuna, and munchkin is going to be less, so it goes there. Slide it over. Now parse compared to tuna. Parse would slide here. And now that the one list is done, they're exhausted, so we just go to the other one, and whatever's left there, dump it in to our merged sort. All right, and so thus we have merged together our 2 lists of strings. All right, so again here, if we were trying to merge these 2, it would depend on how you wrote compare-to, right? We could put them in order by their names alphabetically, or we could put them in order by their GPAs, right? So the way we originally wrote this compare-to, it does it by GPA, right? So what it'll look like is it'll just compare with the IDX, same as before, and it's going to select the smaller of the students, right? So we have 3 students here, 2 students here, and we're just going to merge them into one array that puts them in order, right? So these are already in order by GPA, but then it just merges. So it says IDX1 compared to IDX2. The one with the smaller GPA is Farwell here, student name Farwell. These are little student objects. Sorry if that's not clear. They have name and GPA. Farwell gets merged there. Then we move it over, compare. The lesser GPA is the 4.0. So that one slides here. And then for this one, now, sorry, we're comparing these 2, and we take the smaller of them. And now this one's done, so it just throws in everything else from this remaining one. And thus we have them merged by GPA. All right, I'm going to have to make video part 2. Sorry, this is kind of a long explanation, but go on to video 2, and hopefully it'll finish up these notes.